Okay, let me go back here, share my screen. Okay, so now we're recording. Thank you. I don't remember who reminded me, but yeah, thank you for reminding me to do this. So let me go back to um the assignment. Okay, um, so I'm just going to proceed with question number two. Hold on, let me see here. Uh, Nicholas, thank you very much for reminding me. All right. Um, I'm just going to proceed with question number two. Question number one is relatively easy, so I don't think I need to go over that again for the purposes of recording. I'm just going to proceed with this question here. As I said before, just to remind you, isotopes are different atoms, well, atoms of the same element that has different mass numbers, right? And the mass numbers are different because the number of neutrons are different. And I was making the point that for each element where you have different isotopes, the isotopes exist in the universe in different proportions, right? So the example that is used here in this question is in the case of magnesium, which exists as magnesium 24, 25, and 26. And here we have the abundance of these isotopes. So magnesium 24 is the most abundant at 78.70%, followed by magnesium 25, which is 10.13%, followed by magnesium 26, which is 11.17%, right? And these numbers here to the extreme right of this table would be the mass values, not the mass numbers, but the atomic masses for the different isotopes. And the units of atomic mass that is used is AMU, all right? Atomic mass units, all right? So this question is asking for you to calculate the average atomic mass of the magnesium given this data right here, all right? So this is the way you go about calculating it. I'm going to need some space here, so let me scroll down here. So it's rather a simple process. All you have to do is, let me clear this here. Okay, so all you have to do is take the mass of each of the isotopes. So let me start off with the magnesium 24. You take the mass, which is 23.98504 AMU, and you're going to multiply that by the 78.70%. So that's 78.70%, which you have to divide by 100, of course. And you work that out. So let's do that calculation. Times 23.98504. So according to my calculation, now you have to, of course, round off to the correct number of sig figs. In this case, this works out to be, according to my calculation, 18.88. And if I make a mistake, if you think I've made an error, please let me know, all right? But this is what I got in the case of magnesium 24. And then you're going to do the same thing for the magnesium 25. So in the case of magnesium 25, the mass is 24.98584 AMU multiplied by 10.13 over 100. So let me do that calculation. 0.3 times 24.98584. And according to my calculation, this works out to be two. Again, I have to round off to 4 sig figs, so that would be 2.531. 2.531. Okay, somebody's messaging me. Let me see. Oh, okay, thank you. 2.531. And again, the units, man, these messages are coming fast and furious. Okay, no problem. So this is AMU. Okay, and then we do the same thing for magnesium 26. So for magnesium 26, we take this number, which is 25.98584 259 AMU multiplied by 11.17 divided by, okay, what's going on here? Divided by 100. Oh, by the way, this should be 100, not 1,000. So let's see what this gives. 117 times 25.98259. And according to my calculation, I got 2.8, how many sig figs? 4 sig figs. So 2.899. I wonder if I did this correct. Let me try this again. I think I may have made a mistake. 0.1117 times 25.98259. Okay, I know I made a mistake. That should be 2 point. Somebody's messaging me again. Let me see. Yes, 2.902. I just redid it and I realized my error, 2.902. So let me correct this right here. So this will be 2.902. And then what we do is add this up, right? So we're going to add 18.88 plus 2.53 plus 2.902. And since we're adding, we have to round off according to the lowest number of decimal places, which will be 2. So the final answer here is going to be 24.31 AMU. And that would be what the question is asking for. And you'll notice in doing this question, we not only take into account the atomic masses of the isotopes, but we take into account the percent abundance as well. And that's how we do this, right? And this is basically how we get the atomic masses of all the elements that you'll see in the periodic table. Oh, there's another text here. Okay, thank you. Yes, 24.31. Yes. That's how, if you go to any periodic table numbers, right? And that is different from the mass number, right? The mass number, as I said before, is the number of protons and neutrons present, the total number of protons and neutrons present in the atom. The atomic mass is basically the weighted average atomic mass of the elements, taking into account all the isotopes and their percent abundances, all right? Okay, any questions about this particular problem? Any questions? Okay, now what I'm going to do, whoops. Oh, wait a minute, somebody has a question. Oh, okay, good. Let me clear this. And what I'm going to do, in the interest of time, I'm going to leave this question for you to do. All right? Now, let me just say that this question is going to be a bit of a challenge. Because in the case of this question, they're talking about 2 isotopes, right? It says that the atomic weight of, and these are 2 isotopes of copper, by the way, all right? And the question says that the atomic weight of copper is 63.546. Now, that would be the average, the weighted average, which is what we calculated for magnesium in the previous question. Now, what the question is asking for in this case is the percent abundance of each isotope, all right? And they gave you the masses of each isotope, all right? So it's kind of like the reverse of what we did in the case of the magnesium question that we did earlier in question number 2. Because in question number 2, they gave us the percent abundances, they gave us the atomic masses of each isotope, and we were to calculate the weighted average atomic mass. In this case, they gave you the weighted atomic average atomic mass, and you're asked to find the percent abundance, all right? So I'm going to leave that for you to do on your own. If you have any problems doing it, please feel free to contact me and I'll help you along, all right? So I'm going to skip number 3 for you to do on your own. And I'm going to move on to question number 4, which is this question right here. And this is relatively easy. Um, Basically, what they're asking for you to do is to write the symbol or name of the element, depending if you're given a symbol, write the name, or if you're given a name, write the symbol, and indicate the type and group to which it belongs. Now, type refers to whether or not the element is a metal, non-metal, or metalloid. All right. And the group would be the group number, right? Group 1 or 1A, 2A, whatever. All right. So in the case of potassium, the symbol for potassium is K. All right. It's a metal and it's in group 1, or the alternative system we'll call that group group 1A. As you may or may not know, there are two systems in terms of designating the group numbers. I'm sorry, this group 1A. The older system, which is what I'm more familiar with from my high school days, is just simply group 1 for the first group. And then years later, the powers that be decided to have a different system. Well, actually, the older system is this right here, Group 1A. The newer system is Group 1, right? So this is what I'm familiar with from way back when. And then somewhere along the line, they decided to change the rules and basically designate what was considered to be Group 1A. They designated as Group 1. And to be perfectly frank, both systems are used today. So it doesn't matter which one you use, all right? Okay, in the case of arsenic, the symbol is As. Now, arsenic is known as a metalloid, all right? And the group number would be group 5 or 5A. And then iodine, the symbol is I. The designation here, it is a nonmetal, and it would be in group 7. Well, actually, according to the new system, it would be in group 17 or group 7A. So it doesn't matter again which one of these you use. All right. And then continuing. Okay, let me clear this here. Iron. The symbol for iron is Fe. The group number. Now, again, there's a difference in let me look at my periodic table here for iron. In terms of well, iron is a metal, so no confusion about that. But in terms of the group number, there is the possibility of either group 8B, according to the older system, or simply group 8. So, of course, you'll have access to the periodic table, so you can, refer to it when it comes to answering questions like these. And then in the case of calcium, well, in this case here, they gave you the formula, so you need to write the name. And again, calcium is a metal. And the group number for calcium is group 2A, which is the older system, or simply group 2. All right? And that's basically how that is done. All right? Okay, any questions about this one? Any questions? Any questions? All right, let me clear this. And scroll down. Okay, empirical formulas. Again, this is something that you should have met before in introductory chemistry or high school chemistry. Basically, there's a difference between what is called the molecular formula. Let me write this down over here. We'll bring up the pen first. Okay, so briefly, let me just describe what the molecular formula is. The molecular formula gives the number of atoms of each element per molecule and then the empirical formula gives the smallest whole number ratio of the atoms of the different elements. I hope you can make out my handwriting. I'm sorry about that. Atoms of different elements in the compound. All right. For some reason, when I'm using this particular tablet here, I can't have full control over the writing here. Okay, so that's the difference between the molecular formula and the empirical formula. The molecular formula gives you the number of atoms of each element present per molecule, while the empirical formula gives you the smallest whole number ratio of the atoms of the different elements in the compound. So basically, when it comes to getting from the molecular formula to the empirical formula, what you'd have to do is divide each of the subscripts by a number that can divide into it without leaving over any remainders, all right? So, for example, in the case of the first one, the formula given is C6H10O2. So that means that in this particular case, you divide the 6, the 10, and the 2 by 2, and therefore the empirical formula in this case would be C3H5O. All right? So that's the answer for 5A. In the case of 5B, in this case here, you divide each of these numbers here by 3, so the answer becomes SiO3. All right? And in the case of N2O4, obviously you divide these numbers here by 2, so you're going to end up with NO2. All right? And let me scroll down. Now, in the case of, oh, somebody's saying something. Oh, thank you. Yeah, thank you, Catherine, for the answer for the first one. Okay, so let me clear this here. So for CH4, well, in this case here, and there are situations where this occurs where the empirical formula and the molecular formula will be the same. All right. So that's the answer for E. And then in the case of F, you have 4 and 4 here. So the answer is simply SN as the empirical formula for that particular compound. All right. Okay, so that's relatively easy. Don't think there should be any questions about these. So let me clear this and scroll down to the next. Oh, this one, I can't just leave this for you to do because basically all you have to do is write down the charges for the ions, right? Now, I don't know if I told you, I think I did. The table that you'll have access to, which is the table, the document which contains like the periodic table and so on, also have a list of ions, or actually 3 pages with a list of ions. This link right here, tables chemistry. Let me download this here. Okay, so this is a table that you'll have access to during your exams. Oh, somebody's saying something in the chat. Oh, okay, so somebody's asking, do we just do the negative or positive or the number associated? And the answer is yes, the number associated along with the sign in answer to those questions. So I just want to show you guys which tables you're going to use. I got it. Okay, I don't know what. Okay, so it's scrolling. It's lagging actually. Okay, so this is one of the tables. I'm just going to turn it around so you can see. This is one of the tables which gives you the list of ions, right? So in the case of the first question, which I think is aluminum, you just write down +3 because that's the charge associated with the aluminum ion. All right. So this is the table you're going to use, and there are 3 pages. You have this page, you have this page, and you have this page. All right. And the reason why I included these pages is because there are some ions that is indicated in one page but not the other, right? So I just decided to just put those 3 together so that you have access to all those common ions. All right. So so that's basically what you're going to refer to in order to answer these questions. Where is it? Right. So in the case of aluminum, the aluminum ion will have a +3 charge. So you just put +3 here. In the case of the hydroxide ion, that would be -1. In the case of the oxide ion, that would be -2, and so on and so forth. So all you have to do is just refer to the table and write down the charges. All right. So I'm going to leave the rest for you to do. Right. That's relatively easy. Shouldn't be too much of a challenge. Okay, so now we're going to get into the next question, which deals with nomenclature, right? Basically, what we're talking about here is how do we name compounds, all right? And firstly, what we're going to look at is how do we name ionic compounds. As you all know, or should know, ionic compounds are made up of ions, right? And ions have charges. And based on the charges, you can determine what the formula for the compound is, all right, if you know what the ions are, or if you know the name of the compound, then you can determine the formula, right? And that's what this question is asking for you to do. It says here to provide the names or chemical formulas for the following, right? So in this case, they gave you the formula and they're asking for the name. So what you could do is refer to the table, right, to figure out the name of this compound. Now, in this particular case, you have to be careful because if you go to the table, you'll notice that there are 2 types of chromium ions. You have chromium 3 plus, which is known as chromium 3. That's a name. And the 3 would be written in Roman numerals with parentheses around it. And then you have chromium Cr2 plus. And the name of this is chromium 2. All right. So the question now becomes, well, the second part is easy. The second part is nitrate. So we know it's chromium nitrate, but the question is it chromium 3 nitrate or chromium 2 nitrate? So how do we know which it is? Well, the answer lies in the charge carried by the nitrate ion. If you look up the nitrate ion, you see that the nitrate ion has a -1 charge, right? And you'll notice that this 3 here indicates that there are 3 of them, right? So if there are 3 nitrate if there are 3 nitrate ions, then the total charge here would be -3 carried by the 3 nitrate ions, right? And because the ionic compound is electrically neutral, that means that the chromium here must carry a +3 charge to counteract the -3 charge. So in other words, the chromium ion is the chromium 3 plus, and therefore the name of this compound would be chromium 3 nitrate. So that's the name of CrNO33, chromium 3 nitrate. All right. Okay. Any questions about this one? Any questions about how I arrived at the answer? Okay, somebody's saying something here. Okay, so, okay, Catherine is saying 3. Um, oh, Okay, so Kayla, I'm not sure the last question you asked, plus three or just plus. That I think is in reference to the previous question, right? Okay, yes. So the answer is plus three. You have to put plus three. Okay. Oh, yes, I did answer it. Okay, good. All right. Okay, but I want to know if everybody understands how I arrive at this answer right here, chromium 3 nitrate. I want to make sure that you all understand how I arrived at that. All right. Um, okay, in the case of B, they gave you the name, which is silver nitrate, right? So again, you're going to use a table. So you consult the table and you look up the formula for the silver ion, and you see that it is Ag plus, right? And then you look up the formula for the NO3 minus ion, NO3 minus. Now, if you look at this particular situation, the number of plus charges and the number of negative charges are the same. So when you put them together, you don't need to multiply any of them by anything because they're the same. So therefore, the final answer is going to be AgNO3. And that's the final answer. AgNO3 will be the answer for number 7B. All right. And somebody um, is asking a question here. Yes, that is correct. Exactly. AGNO3. That's for Catherine. All right. Okay. Any questions about this? Any questions? Any questions? All right. Let me hear what you have to say about C. Let me clear this first. And let me scroll down. Okay. So let me hear what you have to say about C. What do you think the name of this compound is? Okay, let's see what this person says. No. No. You have to use the same process. Who is this, by the way? Oh, Kayla. Okay, so not quite. You have to use the same process that I described earlier. Um, so you have to go to the table. Okay, let's see. Somebody said chromium 3 oxide. And that is indeed correct. And to answer your question, Kayla, you said you can't find O3, and that's because there's no O3. What you look for is the oxide ion, right? So basically, when you consult the table, right, you're going to see O2 minus, right? That's the oxide, okay? And as somebody correctly said, the chromium here would be of the form chromium 3, right? Because in order for you to get these numbers here, you'd have to multiply this by 2, this by 3. When they come together, you're going to get chromium Cr2O3. So therefore, the name of this compound would be chromium 3 oxide. All right? So that's the name of that compound. Okay, somebody's texting here. Okay, you're welcome, Miss Catherine. Okay. Um, any questions about this one? Any questions about Cr2O3, the answer being chromium 3 oxide? Any questions? Any questions? No questions? All right, let me hear what you have to say about D. Let me clear this first. And scroll down. Okay, what say you is the answer for D? Now you have to be careful again because iron can exist in two forms. Let me see what this person is saying. Iron 2 nitrate is indeed correct. So let me write that down here. Fe, I'm sorry, iron 2 nitrite. All right. Okay. Any questions about this one? Do I need to explain this one? Do I need to explain it? Okay. You know what? In interest of time, I'm just going to leave the others for you to. Oh, no, before we even do that. Okay. All right. Let me go through the rest of these because I need to make a distinction between how we name ionic compounds and molecular compounds. So for this one, what do you think the answer is for this one? Lead 4 acetate. And again, you have to use a table. Okay, so what's the answer? What do you think the answer for lead-4 acetate is? The formula, that is. Okay, let's see what this person says. Okay, I would agree with you there. Of course, you should not use lowercase letters, but for the formulas. But anyway, it will be PB, then open parentheses, C2H3O2, close parentheses, and then 4. All right? And that's because the formula for lead-4 um, ion, lead-4 plus ion is that, and the formula for the acetate ion is C2H3O2 minus. And because you have a 4 plus charge here, that means that you need to multiply this by 4. And then when you put them together, you're going to get that as your answer. All right. Now, thank you. Now, let me just say this. All the examples or all the ones that we have looked at so far are ionic compounds, right? And one thing about naming ionic compounds is that we do not indicate the number of atoms present in the name of the compound. So in other words, we don't use prefixes like mono or di or tri, etc. We don't use those prefixes when we are naming ionic compounds. We do use prefixes when we're naming molecular compounds, such as this one right here. So for example, in the case of F, the name given is dinitrogen trioxide, right? And that indicates the number of atoms of each of the elements involved, right? So let me clear this first. All right, so in the case of dinitrogen trioxide, the formula will be N2O3, and that's it, right? 2 nitrogen atom, that's where the dinitrogen comes from, and the 3 oxygen atom, that's where the trioxide comes from, all right? So in the case of G, it's a reverse. So my question to you is, what do you think the answer is? They gave you the formula, so what do you think the name is? Okay, let me see what this person says. Tetrasulfur tetranitrate, not quite. Almost there, but not quite. Let me see what this other person says. Tetrasulfur. Oh, only one person answered. Okay. Um, no, not nitrite. Again, very close, but not quite. The name of this compound is tetrasulfur nitride, IDE. All right? I'm sorry, tetranitride. My bad. Tetranitride. Tetrasulfur tetranitride. Here's the important thing that you need to remember when it comes to naming molecular compounds. This is called a binary molecular compound, right? A binary molecular compound is basically a molecular compound which has 2 atoms in it, all right? And basically, when you're naming these compounds, the second element in the name must end with IDE, right? So nitrogen becomes nitride, sulfur becomes sulfide, oxygen becomes oxide, and so on and so forth, right? So therefore, when it comes to binary molecular compounds, the second element, the ending of the name of the second element must end with IDE. All right? Okay. So that's G. And then in the case of H, now this is ionic. So what I would do is look up the formulas of these ions here. And I want you to tell me what the name of the resulting compound is. Okay, let's see what this person says. Okay, so this person says potassium perchlorate. Not quite, because the perchlorate ion is ClO4 minus. This is ClO. So you have to look up the formula for ClO minus. Exactly. Kayla, you're correct. So the name of this compound is potassium hypochlorite. All right. Okay, very good. Let me clear this. Scroll down. Okay. And number 8, basically they're asking for the formula based on the name and vice versa. Whoops. Okay, what did I do? Okay. So I'm going to leave you to complete that. All you need is a table in order for you to answer those questions. So I'm just going to leave that for you to do. And then this one here, basically is kind of similar to what we did earlier. Basically, they gave you the ions and they're asking you to write down the formulas. So I'm just going to go through one or two of them. So let's look at 9A. What do you think the formula is? Anybody? Come on, guys, this should be easy. Okay, let's see what this person says. That is indeed correct, Catherine. The answer is Ca3, open parentheses, PO4, close parentheses, 2, right? And that's it. And the second one is even easier because you have a +1 charge here, -1 charge here, so that's KNO3, and so on and so forth. All right, so I'm going to leave the rest for you to do in that section. Question 9, let me clear this here, and let's scroll down. I want to do as many as these within the time constraints. Okay, for number 10, is asking for you to predict whether each of the following compounds is either molecular or ionic. Basically, molecular compounds are made up of exclusively nonmetals. There are some exceptions, but for the most part, that is the case. Ionic compounds involves a combination of metal and nonmetal, all right? So what do you think the answer is for A? Is that ionic or molecular? Okay, let's see what this person says. Ionic, okay, that's correct. What about B? NOCl2, NOCl, I'm sorry. Is that ionic or molecular? Okay, let's see what this person says. No. Remember, molecular is made up of nonmetals, right? And these elements here are all nonmetals: nitrogen, oxygen, and chlorine. All right, so the answer for this one would be molecular. What about C? Okay, let's see what this person says. Ionic is indeed correct. And then let me scroll down. SCl2, is that molecular or ionic? Molecular, that's correct. And ALN, aluminum nitride. Is that molecular or ionic? Let's see here. Ionic is indeed correct. Okay, very good. All right, and I think that's it for that question. Okay, now for the rest of these, it's basically dealing with nomenclature. In fact, let me just check something here. Yes, these are all nomenclature type questions. I don't think we'll be able to go through all of them, but what I can do is give you a start in the different sections, and then you can do the rest on your own. So what I'm going to do here is maybe the first line in this one right here. So the first question says, give the formula and the name of the compounds formed between each pair of the elements listed below. And they gave you beryllium and fluorine, right? So what I would do is consult the list of ions, which I showed you earlier, and I would look for the formula for the beryllium ion and the fluorine ion, or the fluoride ion, I should say. So the formula, if I look it up for the beryllium ion, is Be2 plus, and the formula for the fluoride ion is F minus, right? And then what I would do is try to make sure that the total number of plus charge and negative charges are the same. And the way I do that in this case is that I'll multiply the fluoride by 2. So you end up with 2 negative charges, which cancels out the 2 plus charges. So therefore, the final answer for the formula would be BeF2. And the name of this compound would be beryllium, beryllium fluoride. And that's it. Okay, and that's it. All right. So, oh, somebody said something. Let me see here. Okay, thank you. So that's basically how that is done. All right. So if you understood this, then you should be able to complete that table. So I'm going to leave the rest for you to do in that table. And let me clear this. Scroll down. In this case here, it's kind of similar to the previous question. In this case, you're given the formulas and you're asked to name these compounds. So in the case of the first one, again, you'd have to consult the tables. And basically, once you consult the tables and, oh, somebody's saying something. Let me see here. Maybe this person is answering this question. Okay, so somebody says calcium chlorate. Not quite. Close, but not quite. Again, you have to consult the table. Yes, somebody says the right answer here. Calcium chloride is indeed the answer. Exactly. So the name of this compound here is calcium chloride. Remember, you have to consult the table, right? The table gives you the names of the different ions. So the name of this compound is calcium chloride. All right? What about the next one? Now, the next one you have to be careful because in the case of iron, if you consult the table, you'll see that there are two types of iron ions. All right? There's iron 2 and iron 3. All right? So you have to figure out which one of those ions would be present in this particular formula. So let me hear what you have to say about this one. What do you think the answer is? Let me see if anybody. What do you think the answer is? Okay, let's see what this person says. Iron 3 nitride is indeed not correct. Iron 2 nitride. Thank you, Catherine. So the name of this compound is iron, 2 nitride. All right. And the reason why that's the answer is because iron 2 is this formula right here. The nitride is N3 minus. So in order to get the charges balanced out, you're going to need 3 of these and 2 of these. And when you put them together, this is the formula that you're going to end up with. So therefore, the iron ion is the one that carries a +2 charge that would be in the formula, and therefore the name of the compound is iron 2 nitride. All right? Okay, So again, in the interest of time, I'm going to leave the rest for you to do, but that's basically the approach that you're going to take. Let me clear this here. And then we get to these right here. Now, this is just the reverse, right? I'm not going to go through these. It's just the reverse of what we just did. In other words, you're given the names and you're asked to write down the formulas, all right? So I'm going to leave this for you to do as well, since we don't have a time. Now, when it comes to naming acids, this one is a bit involved, but basically you can name the acid based on the corresponding anion, right? And let me just go through this quickly. I'm quite sure I covered it extensively in the videos, but basically if the ion name ends with ATE, for example, NO3 minus, right? This is called a nitrate ion. Nitrate ion. To get the corresponding acid, we add H plus to it. This becomes HNO3. And the name of the acid is nitric acid. All right? So if the corresponding anion is nitrate, the corresponding acid is nitric. And the same is true for sulfate. The corresponding acid is sulfuric. What's the other one? Acetate, the corresponding acid is acetic, and so on. So if the anion names end with ATE, the corresponding acid name ends with ic acid. And then you have, if you're dealing with an anion like NO2 minus, which has the ending, which is the name of it is nitrous, right? The corresponding acid would be HNO2. Oh, I'm sorry, my bad. The name of this ion is nitrite. This is called a nitrite ion. And the name of the corresponding acid is nitrous acid, right? So in this particular case, if the name of the anion ends with ITE, then the name of the corresponding acid ends with OUS acid, all right? And there's another thing I need to say about binary acids, like this one right here. A binary acid, I'm going to use HCl as an example. Now this compound, this compound here, HCl gas, this is known as hydrogen chloride. All right? When you add hydrogen chloride to water, the corresponding acid HClAQ is known as hydrochloric acid. All right? So what we're talking about here is what is called a binary acid, which means that it's an acid which contains only two elements, in this case, hydrogen and chlorine, right? So if the name of the binary hydrogen compound here is, ends with, well, it starts off with hydrogen, the stem of the name of the other element, and IDE. The name of the acid is hydro, the stem of the name of the other element, and acid, right? So hydrogen chloride becomes hydrochloric acid, hydrogen bromide becomes hydrobromic acid, and so on and so forth, all right? So the difference is that between these two is that this is in a gaseous state and this is dissolved in water in the aqueous state, right? Okay, so that's what you're going to need in order to answer these questions. So I'm going to leave this for you to do. If you have any problems while doing these problems, please feel free to contact me and I'll help you with it, because unfortunately, I can't cover everything in the remaining 6 minutes that we have, or I should say the remaining 3 minutes that we have here. And this is the reverse, where they give you the formulas for the acid and they're asking for the names. And then here is basically a miscellaneous group of compounds, acids, molecular compounds, ionic compounds, etc., for you to write the formula if given a name and vice versa. And same thing here. And this deals with hydrates. Let me answer the first one in this case, and you should be able to, based on that, do the rest. So in this particular case here, the way we name the hydrates is that we name the ionic part first here, just like how we would name any ionic compound. But next, we have to indicate the number of water molecules. And this is how we do it in this case. We start off with the first part, which is the calcium chloride, calcium chloride, right? So that takes care of this part here. And then the way we indicate the number of water molecules is that we indicate using a prefix here. So this would be octahydrate. All right. Octa means 8, and hydrate, of course, means water, right? So the full name of this compound is calcium chloride octahydrate. All right. Let me help you with the other one. In the case of this one, this is called iron 2 sulfate hexahydrate. All right. And basically, you follow the same trend in answering the rest of them. All right. And then the next part of question number 16 is the reverse. So they gave you the names. Let me clear this here quickly. They gave you the names, and you're asked to write down the formula. So you should be able to do that if you understood how to do the first part. Let me see what's next. Okay, so this is just basically asking you to fill in the prefixes for the different numbers of atoms and some last questions here for you to fill in the spaces, and that's it. All right. Okay, so, and then some other questions here in naming. Um, and this is for molecular compounds, and this is where the prefixes will come in. Unfortunately, I won't be able to do all of them. All right, so what I'm going to do now is open up a Dropbox for this assignment. And because of the length of this assignment, I'm going to give you a bit more time to complete this. So let me go here, assignments. Okay, so this is assignment number 2, right? And let me set the deadline date for this. So, okay, this is the 27th. Okay, I'm going to give you until mm, hold on, let me do the I'm going to give you until Friday. And the only reason why is because I want to grade it and get it back to you because your next test will be on the 9th. Your first test will be on the 9th of February. I want to grade it and get it back to you so that you can have it to review. All right. So let me do this here. Um, so the due date is going to be the 30th. It's going to be available from now, which is the 27th, until the 30th. Okay, so now it is set. You should be able to upload your assignment into the Dropbox provided. Please, 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 when you're submitting your assignment, remember the rules I set forth for you to submit the assignment. Make sure it's in PDF. Make sure you do it on the original document. There's some other things I need to mention. I'm going to post it in the announcement based on what I saw in grading assignment number 1. Now, somebody has a question here. Yes, the test is set for February the 9th. So I want to grade it and get it back to you. Actually, let me take that back. The test is set, the schedule for the test is for the week of February 9th, because remember, you're doing it in the testing center. So you're going to have actually from the 9th to the, hold on 1 minute, February. from the 9th to the 13th, right? So I'm going to say more about that, but basically, you're going to make the appointment or set the appointment at the testing center for that week so that you can go there and do the test during that week. All right. Okay. I think that's it for today, folks. I have another class following. Okay, how long the test is? Same as the length of the class time, which would be 75 minutes. All right. Okay. Have to leave because I have another class right after you guys at 11. So that's it for today. If you have any questions, feel free to contact me during office hours, and I'm more than willing to help you. All right. Okay, so that's it for today, folks. I have to depart. So until next time, I'll see you guys.